couple of reminders. Slope, formula for slope. The distance formula, which we will use, the distance between 2 points is the square root of x minus x squared, y minus y squared, so the 2 points. The midpoint formula, you take x1 and x2 divided by 2, y1 and y2 divided by 2. The equation of the line in slope-intercept form, in slope formula form, so this is just another way of writing it. Slopes of parallel lines are equal, and slopes of perpendicular lines are negative reciprocals of each other. So on these two lines, if as I said, this slope y is equal to -2, this perpendicular line, and I didn't do very good at perpendicular, its slope would be the negative reciprocal, would be +1/2. Okay, so let's try a problem here. Use coordinate geometry to prove that the midpoint of the hypotenuse of any right triangle is equidistant from the vertices of the triangle. So what we're going to do is we're going to do an arbitrary triangle on the xy plane. And I'm going to do it very smart by putting it at the origin. I could move it over, but that would just make more work for myself. Then what I'm going to do, step 2, is I'm going to label using variables. So if I call this point A, B, and C, across from point B is line B and line A. And so I say between C and A is B away. So my x value is 0 because I'm at the origin. I just go up. My y value is B. Here we have A away and we're still on the y, so it's 0. The midpoint is going to be A over 2 and B over 2. And again, I'm trying to prove that the midpoint of the hypotenuse is the same distance from the vertices of the triangle. Okay. So now what I'm going to do is I'm going to use formula to create equation related to the focus. I'm going to use the distance formula. The distance between AM squared, remember distance formula was up here, distance is equal to, and I just squared this side, so I took away the square root side. Okay. The distance is equal to, squared is equal to 0 minus a over 2 squared plus b minus b over 2 squared. So just the distance between the x and the y squared. Okay? Simplifying, I get a squared over 4 plus 2b minus b over 2. So I'm just making a common denominator. And finally, simplifying, I get a squared over 4 and b squared over 4. Now I'm going to find the distance between b and m. So that's now between here, b and m. And I'm going to show that that's the same distance as well. Okay, so this is, whoops, not what I wanted to do. A minus a over 2 and 0 minus b over 2 squared. Simplifying that, once again, I get a squared over 4 plus b squared over 4. So that shows me that those distances are the same. Okay, and now I need to clearly state based on evidence. The midpoint is equidistant from the vertices. The midpoint is the same distance away. So I put it on a coordinate plane to do this. So before, some of you might say, well, that's obvious. It's the same distance from the vertices, but we proved it, which is what we're trying to do. Okay, use coordinate geometry proof to show that the diagonals of a square of a perpendicular are perpendicular and congruent. So if I drew a diagonal, I would be able to they would be perpendicular and congruent. So the first thing we have to do is we have to label the vertices. Well, A is obviously 0, 0. B, the x value is 0, the y value is A. C, we are A up and A over, so it's AA. And D would be A0. And I think that's what I did here. Good. Okay, now we need to show that BD is equal to AC. The line BD is equal to AC. And we need to show that the slope are negative reciprocals. Why? Because we are trying to prove that they are perpendicular and congruent. So congruent is fine. Perpendicular means we have to show they have negative reciprocal slopes. Okay, so here's how we're going to go about that. Oops. So the distance BD is equal to 0 minus A minus 0 squared. So squaring that, we get a squared and a squared, or 2a squared. Okay, the distance AC, same thing, we get 2a squared. So I've already shown that those things are congruent. Now I just need to show that their slopes are the same. So here we go, the diagonals are congruent. Their slopes are not the same, sorry, they are negative reciprocals. The slope of BD is equal to, remember, it's y2 minus y1 over x2 minus x1, so it equals negative 1. The slope of AC is equal to 0 minus a, 0 minus a, so simplifying that gets positive 1. So this shows that they are perpendicular. So BD is perpendicular to AC, so the diagonals are perpendicular, and that is what I was trying to prove. Okay, so make sure to read the examples in your textbook, try a couple questions, and get familiar with this concept.